What's up, interweb? Today we're going to talk about the slope of a line given 2 points. We're going to calculate what the slope of the line is given 2 points. It's a real simple equation. A slope, for some reason, we call M. Don't know why, it just is. So the slope is M. We're going to use this quite a bit, so etch that on the inside of your contact lenses. Now the formula to calculate slope is real simple. It's M, which is slope, is y2 minus y1 over x2 minus x1. Remember, x and y are points on the graph. So if you're given these 2 points, 2, 3, and 5, 6, what is the slope of the line? Very simple. Now remember, points are always in the form xy, xy. Okay, this is the first coordinate, so we call it x1, y1, but again, it does not make any difference. You can use this one as x1 and y1 also, and this one x2 and y2. Okay? Okay. Now, again, slope is y2 minus y1 over x2 minus x1. So all we do is plug in the numbers. Y2 is 6. Did everybody see that? 6 minus 3 minus y1 over x2, which is 5, minus 2, x1, which is 2. Now remember, the fraction bar kind of acts like parentheses. So we're going to do the numerator and denominator first. 6 minus 3 is 3 over 5 minus 2 is also 3. So our slope is 1. Okay, these are really very simple. Excuse me. About the only time they get, let me do another one like this. If it passes through these 2 points, 6, 4, and 8, 10. And remember, x1, y1. Why can't I get my stupid fat hand out of the way? x2 and y2. Now we plug it into this formula. Slope equals y2, which is 10, minus y1, which is 4, over x2, which is 8, minus x1, which is 6. Now we do the arithmetic here. 10 minus 4 is 104. Yeah. 6. 10 minus 4 is 6. 8 minus 6 is 2. Now be sure and reduce the fractions here, or get your 7-year-old brother or sister to help you. 6 divided by 2 is 3. So that's our slope. Now, the only time these things get even the slightest bit difficult is when we've got the godless negative numbers. So what if you're given -5 and -7 and -9, -15? Okay, our formula is, and again, x1, y1, x2, y2. So y2 is, so our slope is -15 minus a -7 over x2 is -9 minus a -5, I think. I'm going to rewrite this. You don't have to, but -15 minus a minus is a plus. over, and again, -9 minus a minus is a plus. You can think of this as -1 times -5, or you can think of it as the opposite of. Negative also means the opposite of, so the opposite of -5 is a +5. Now we do the arithmetic. We get negative, what is it, 8 over -4. A negative divided by a negative is a +2. Okay? Okay. Now, zero slope is a horizontal line. O-R-I-Z-O-N-T is a horizontal line, like that. Okay, you can think about it kind of like the old time, back in the day we had, well, you've got them today too, speedometers. Here you're going, what, about 60, 50, 40, 30, 20, 10, blah, 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 all the way to you're stopped and 0, right? So our slope here is 0. Okay, again, 60, 50, 40, blah, 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 0. 5, 4, 3, 2, 1, 0. Right? Horizontal line is 0. No slope or undefined slope, U-N-D-E-F-I-N-E, undefined slope, mean the same thing. Or, no slope or undefined slope is a vertical line. Okay? And you're going to see this, not a whole bunch, but you are going to see it from time to time. This is another one of those things you just need to memorize. Excuse me. That COVID is eating me up here, I'm afraid. So the best thing for that is drink you some Diet Coke. Mm-hmm. Parallel lines. If you don't remember what parallel is, the way I remember it is look at the two L's in parallel. They're parallel. Okay, both of these lines are, pretend that they're parallel. Okay, what happens here with parallel lines, they have the same slope and different F-F-E-R-E, different y-intercepts. What that means on the graph, if you have two lines, slope is 1, more or less, and it crosses the y-axis right here. This is the y-intercept, x and y. And then you have another line. Let's pretend that that's also a slope of 1. You can see that these lines will never cross. I know never's a long time, but parallel lines will never cross. And these particular ones have a slope of 1, but again, it doesn't make any difference. But they have a different y-intercept. They will never cross. Y-intercepts are different. If they have the same slope and the same y-intercept, what do we have? One line right on top of another one. Okay? Those would be the same lines. Now, perpendicular, P-E-R-P-E-D-D-I-C-U-L, perpendicular lines, the slopes are the negative ATIV reciprocals. CPROCA. Now, what the hell does that mean? I mean, what the heck does that mean? Negative reciprocal. The easiest thing to do is to show you. If the slope is 2/3, and I'm going to use this symbol right here for perpendicular slope, because this is what perpendicular is. It's a 90-degree angle. The perpendicular slope is the negative reciprocal. What does reciprocal mean? Flip these numbers over. This one's positive, so, the perpendicular slope will be negative 3/2. Okay, it's the negative reciprocal. Reciprocal means just to, flip these two numbers over. Therefore, if you have the slope is a negative 5/4, then the perpendicular slope will be, if this one's negative, this one's going to be positive 4/5. Reciprocal, flip it over. Okay, if you're so smart, let's see you get this. If the slope is 0, and remember, a 0 slope is horizontal, then what is the perpendicular slope? Get that if you're so smart. The perpendicular slope is no slope, or undefined slope. Okay, so if the slope of 0 is like this, then the perpendicular slope will be like this. Right? Right. Okay. Okay. Sorry about that. All right. Again, I'm sorry, 0 slope, no slope. And that's parallel and perpendicular. Now, I'm going to kind of switch gears a little bit here. You're going to see this periodically. We don't use this a whole lot, but it is used some. It's called standard form. STAN. Standard form. A standard form is AX plus BY equals C, where A, this number here, A must be a whole number, and greater than 0. Greater than 0 means positive. Okay, it has to be a whole number, and it has to be positive. That's standard form. Now, we don't use that a whole lot because it really doesn't tell us a whole heck of a lot. Okay, now we're going to kind of back up a little bit. Equations of lines. Now for this, we're going to use our calculators more for this. Equations of lines. First of all, the one that we use the most is slope-intercept. SLOP. Intercept. INTERCE. Slope-intercept. We use slope-intercept a lot because it tells us a lot. It tells us what the slope is and what the y-intercept is. And the form that this is in is y equals mx plus b, where m is the slope and b is the y-intercept. Slope is the y-intercept. So if we have this, if we have y equals 2x plus 3, our slope is 2, okay, mx plus b, and our y-intercept is 3. Now what in the world does that mean? It means that if you have a nice pretty graph like this, it's going to cross the y-axis at 3, which is about there, and has a slope of 2, which is kind of like that. Pretend that's a line. Now, what you can do is put this in your handy dandy calculator. First, we turn it on. Oddly enough, sometimes I can never remember how to do this, or never remember to do it. Turn it on. Okay, now if you look, our formula says y equals 2x plus 3. So what do? I don't know whether you can see it or not, but this button right here says y equals. So oddly enough, we're going to go there, y equals. Now y sub 1, all of these are different lines. So you can see that you can put more than one line on here. So our equation is 2x plus 3. So we hit the number 2. Do not use this. This means to multiply. That's not x. X, the variable x, is this one right up here. See, right under mode, it says x, t, theta, and n. That's our variable x. 2x, and then plus 3. Now we hit the plus button, and 3. Before you leave this screen, you guys have big fat fingers. You ladies have long fingernails. You're going to hit the wrong keys. So before you leave the screen, look up here and make sure you entered it right. Now we go over here to graph. Oddly enough, that's going to show us the graph. So we hit that. And you can see, even as bad as my drawing is, crosses the y-axis at 3. You can see the little tick marks here. 1, 2, 3, cross the y-axis at 3, and a slope of 2. Okay? Go to y equals, clear it out, and turn it off. Now, this is a positive slope. Positive slope goes up and to the right. A negative slope goes down, O-W-N, and to the right. So let's see. Let's do y equals, well, why don't you put it over here so we can see. Y equals negative 5x minus 1. Okay. Now what's our slope? Our slope is negative 5, and our y-intercept is negative 1. Okay, what's this going to look like? It's going to cross the y-axis at negative 1, which is here. A slope of negative 5 is going to be pretty steep, and will look like that. So let's put it in our handy-dandy calculator and see. First we turn it on. Yeah, we don't care about that. Turn that off. hit clear. Okay, we go to y equals, this button right there, and we get negative 5x. Now when the negative is at the beginning, is at the very beginning, we're going to use this, the negative key, which is here. Negative 5, and remember x is this, not the multiply key. And then minus 1. Negative 5x minus 1. Now we go to graph. See if it looks anything like the one I just drew. See, even as bad as my drawing is, you can see we're right. That's a fairly steep negative slope, goes down to the right, and crosses the y-axis at negative 1. So we are right. Now, if you have this, if you have 3y equals negative 12x minus 6, is this in slope-intercept form? And again, why do we call it slope-intercept? Because it shows us the slope and the y-intercept, ergo the name slope-intercept. Okay, this is not in y equals mx plus b. We need y to be 1, or the coefficient of y needs to be 1. So we divide everything by 3, and we get y equals negative 4x minus 2. Our slope is negative 4, y-intercept is negative 2. Okay, we can put that in our handy dandy calculator. Turn it on, clear it. Y equals, okay, negative 4x. Now remember, when the negative is at the beginning, we have to use that key right here, negative 4. And here's the x key right there. This is the x, remember, the variable x. And then minus 2. We don't use this because it's not at the beginning, minus 2. Double check to make sure you put it in right. Negative 4x minus 2. Hit graph. And there we have it. Oh, I didn't do it. Okay, it crosses the y-axis at negative 2. Has a slope of negative 4. Negative 4 is pretty steep, going down to the right. Okay. Everybody got that? We're going to use this quite a bit, but it's pretty simple, thankfully. Okay, now, point slope. We don't use this quite as much because it doesn't tell us very much. P-O-I, point slope, S-L-O. It's not slop, it's slope. And what you're going to be given at least one of these on the final exam, but they're real simple. The point slope formula is y minus y1 equals m open x minus x1 closed. Looks kind of hard, doesn't it? No, it's not. It's real simple. And what they're going to say is they're going to given that the slope is 3 through T-H-R-O-U-G-H through the point say 2 comma 5. Okay, now again we know that this is x, this is y. Now this y and this x stay x and y. y1 and x1 are these two. So what we do is we just plug in the numbers. Y minus, what's our y1? 5 x1 y1 equals m, or slope, which is 3 open x minus, and x1 is 2. Now you get to this point, and a lot of times my brain goes numb at this point. What do I do now? Well, you can look at it and say, well, what can I do? What does order of operation tell me I want to do first? We're going to multiply 3 times all this misery, the distributive property. So y minus 5 equals 3x minus 6. Is that right? We just multiplied the 3 times everything in here. Now, we want this in slope-intercept form. So we want y over here by its own self. So we're going to add 5 to each side. Remember, you have to add 5 to the y-intercept, not to the slope. So we have y equals 3x minus 1. Okay? What could be more fun? Okay. Now this is about as difficult as these get. If you get that the slope is negative 3, R-O-U-G-H, through the point negative 4 comma negative 6. Again, y minus y1 equals m open x minus x1. Okay, so we have y minus y1 is negative 6 equals our slope is negative 3 open x minus, and our x, remember these are always in the form xy, minus negative 4, closed and closed. So we have y plus 6, minus a minus is a plus, equals, let me do this, negative 3 open x plus 4. Minus a minus is a plus. So we have y plus 6 equals, now we're going to do distributive property here. We're going to multiply negative 3 times everything in here. We get negative 3x minus 12. Negative times a positive is a negative. Now we're going to subtract 6 from each side. And we get y equals negative 3x minus 18. What could be more fun? Okay. Okay. Now you're also going to get this. Going to get, write the equation of the line. Here we are. Passing through the points um, 6, 4, and 8, 10. And 8, comma 10. Now what is it that you can calculate from 2 points? Slope. x1, y1. x2, y2. Okay, so remember slope is y2 minus y1 over x2 minus x1, and take you some Diet Coke. Okay, y2 minus y1 over x2 minus x1. Now we do the arithmetic. 10 minus 4 is, what is that, 6? 8 minus 6 is 2. So our slope is 3. Now what do we have? We have 2 points and we have slope. So what formula do you think we're going to use now? You're so smart. Let's see. Yeah, point slope. Because we have points and we have the slope. So remember, point slope is y minus y1 equals m open x minus x1. Okay? You can use either one of these points. It doesn't make any difference which one. Let's use this one because the numbers are easier. So we have y minus 4, okay, 4, equals m, which is 3. Our slope is 3. Open x minus, we're using this x minus 6. Okay, so we have y minus 4 equals 3x minus dsc ultra. Right? Right. Now we're going to add 4 to each side. Y equals 3x minus 14. Right? Right. What could be more fun? Okay, and the only thing you really have to worry about here is godless negative numbers. And they're going to do that to you. They're going to put some negative numbers in here. But y'all are good with those, so no worries. All right. Y'all take care. Have a good weekend. Bye-bye. Bye, bonds.